Welcome to 3D FireMonkey Programming CodeRage 9 session. My name is Paweł Glowacki. I'm working for Embarcadero as EMEA Technical Lead for Developer Tools. And today I'm going to demonstrate building 3D new generation applications using C++ language, which is part of RAD Studio, XE7, C++ Builder XE7, but in this case I'm going to use a new product from Embarcadero, app method. I'm going to use app method with C++ language, September 2014 release. I'm going to start with a bit of introduction to the graphics architecture of the FireMonkey framework that is powering the 3D capabilities of the integrated development environment, and I'm also going to discuss the objects that are making the 3D hierarchy, so the objects that you are using to build highly interactive 3D applications. And then I'm going to move into a live coding and demonstrate some of the demos that illustrate key features of 3D development with app method and C++. So there are two different types of forms inside of the multi-device applications. There are traditional two-dimensional forms where you can build traditional two-dimensional user interfaces, but there are also special 3D forms that make it easy to create highly interactive, great-looking applications with support for 3D. The architecture behind the 3D development in FireMonkey is based on abstracting away the complexities of the underlying 3D APIs. So you can use any of the two programming languages, C++ or Object Pascal, and then you are using abstractions provided by the FireMonkey framework to actually call different APIs, different 3D APIs on different platforms. So if you compile your multi-device application for Windows, then you are using DirectX. If you compile the same application for Mac, then you are using different APIs, OpenGL, and the same application compiled for one of the mobile targets like iOS or Android is using a special embedded version of OpenGL, OpenGL ES. So this is a very powerful concept where you don't have to be expert in a low-level 3D APIs and different APIs on different platforms. You create your application once with high-level reusable components, and then you can just focus on what your application is supposed to do instead of becoming a math expert in a different matrix transformations and all the funny stuff that is typically related to do 3D programming on a low level. At the end, FireMonkey application is also using the same technology that other 3D frameworks. So our 3D application is calling through the FireMonkey framework the 3D APIs on a given platform, and then the processing to display the actual 3D graphics is happening inside of the graphical processor unit using vertex shaders and fragments shaders. So this is the same technology as is standard in a standard way available either through DirectX or OpenGL. FireMonkey has a special class like in other places within the library. We have typically abstract classes that provide a common interface to functionality implemented on different platforms. So in case of the FireMonkey, the key class here is tContext3D, which provides a uniform access to different underlying APIs. So you are using a context3D functionality, and then eventually your application is calling the right APIs on a given platform. You create your applications with components, so that components are objects that can be manipulated at design time, and there are different 3D objects that you can use inside of your 3D applications. So every FireMonkey object is derived from a TFMX object class. So this is the class that provides support for basic functionality like parenting. In FireMonkey framework, every component can own other components, so this is especially important for 3D programming because all owned or children components are inheriting the transformations of the parent component. So if your parent component is at a certain position inside of the 3D space, then the position of owned components are relative to the position of the parent. Similarly, things like rotation or scaling is also influencing all the owned components. Also on a TFMX object level we have support for animations, so this is also important for the 3D applications where you want your 3D scene to be moving, to have interactivity, use animations a lot. On the next level we have a T-Control 3D class. So this is a base class that is introducing things related to working in a 3D space. So we have properties like position in a 3D space, like scale, like rotation, like common user events, for example on click, on double click. This is very important thing in a 3D programming, that the 3D models that we are creating are interactive. They have events and they can respond to user events, so it's very easy to create interactive 3D visualizations. So there are some very light class objects that are derived directly from T-Control 3D. For example, T-Stroke Cube and T-Grid 3D. So they are very light, so only they are just drawn in a 3D space. They do not contain a vertex buffer or anything like this, so they are quite light and inexpensive to use in a 3D applications. On the next level we have a T-Shape 3D. So this is a component or class that introduces support for materials. So in FireMonkey 3D programming, the material is a separate component, so different 3D objects can reuse the same material. So you can have 3 different types of materials: light material, color material, and texture material. So there are some components that derives from the shape 3D, like for example rectangle 3D or path 3D or text 3D. So these components can have a certain color and can have a certain material. On the next level we have a T-Custom Mesh component. So this class introduces support for vertices, for indices, for face normals. So in a 3D programming it's a typical situation where you have a vertex buffer and indices buffer where you have your geometry of your object. So these there are specialized classes that has these vertex buffers. So there is a T-Mesh class that lets you load arbitrary mesh, and specialized classes that have a mesh already predefined, like sphere, cylinder, cone, T-Round Cube, T-Plane, T-Cube. So as a programmer you don't need to initialize a vertex buffer, so those components have vertex buffers already predefined, so it's easy to work with them in code. There are also some special 3D objects that are used for building 3D visualizations. They are also derived from a T-Control 3D, so they can have a position in a 3D space. So these are components like T-Camera. So you can use camera to specify the point of view into your 3D space. You don't necessarily need to use a camera. Every form 3D, every viewport 3D has a built-in design time camera that you can also use at runtime, but in most cases you want to have a specific camera component to have a better control on the point of view into your scene. There are also light components, so that T-Light component can be directional can be a point light or spotlight. So this is useful for lighting to your scene. There is also tproxy object. So this is a object that is useful where you want to have a lot of different 3D objects, but you don't want necessarily to occupy too much memory for the vertex buffer of each object. So with tproxy object you can create copies of a certain object that share the same vertex buffer, so your application does not occupy too much memory. There is also a very useful tdummy component. So this is a generic 3D container. I have already said that in FireMonkey each object can contain other objects, so it is quite common to use a tdummy as a container for the whole scene. So you have one place where you can position the scene, you can change the scale of all the elements that are inside of the tdummy component. So tdummy component itself does not have any visual representation, is primarily for grouping other 3D components. There is also a special tmodel 3D component that is derived from tdummy, which is useful for loading arbitrary files with a 3D geometry created with other applications specifically designed for modeling 3D worlds and objects. So there are three different file formats that are supported. So you can, in this scenario, when you want to, for example, create a great looking world, you have your 3D artist spending time modeling objects, and then he can export these objects in one of the supported formats, and you can load it to your application inside of the Model 3D component. Okay, so that's a very quick introduction to the object hierarchy of FireMonkey 3D development. And now I'm going to move to demos. So there are different products that I could have used right now for demonstration. I could use either C++ language or Object Pascal language. So these two languages are part of Embarcadero Rad Studio and Embarcadero App Method, or you can use a specific product like C++ Builder for doing C++ and Delphi for you doing Object Pascal development. So all those products have the same support for 3D. In my case, I'm going to use Embarcadero App Method September 2014 edition, and I'm going to use C++ language as my language. So I'm going to switch to demos. So I'm going to start with demonstrating the steps to create a basic interactive 3D application. Okay, so I'm going to jump into App Method. I'm going to create a brand new multi-device application. So I go for File, New, and I have a multi-device C++ application wizard. So I'm going to start with a 3D application template. So that's obvious that I want to create a 3D application. I may start from 3D application. As we are going to see later, this is not necessarily the only possibility to build 3D applications, but let me start from this simple 3D application template. I'm going to click on OK, and in OK, after OK, I have a form, which is a three-dimensional form that I can put here different 3D objects. So on the object palette here on the right hand side, there are different components in 3D categories. So components that are part of the 3D scene, like camera, light, dummy, proxy. I have 3D shapes, so different types of shape components that I can put in the 3D space. And also there are some components for 3D layers. So these are the special components that I can put a 3D layer inside of the 3D space to, for example, use a traditional two-dimensional components. And there are also components in the category materials. So these are the materials that I can assign to different 3D objects in the space. So for this very first demo, I'm going to demonstrate key functionality of 3D development in app method and in C++. So I'm going to actually build a visualization of Earth, our planet Earth. So this visualization, I'm going to use a texture that is available for free from this link, Planet Pixel Emporium, and there is a free color map of Earth, so I can download this map, and this is a texture that I'm going to use on a sphere component. So to demonstrate functionality of 3D development in C++ language here, I'm going to add some animations. So my Earth is going to be rotating, but also I'm going to demonstrate the interactivity, so that elements inside of my 3D screen can react to the user events. Another important aspect and one of the key features is that it's all multi-device and multi-platform. So from the very same source code, I will be able to recompile my application to all supported platforms, including Windows, Android, iOS, and Mac OS X. Okay, so let's start from changing the color of my form to something more similar to deep space. So I'm going to change the color to black, so it's more natural, and I'm going to use just a simple sphere component. So this is going to be my Earth. I'm going to change the name of this component to just Earth, and I'm also going to change the scale of this component. So notice the properties of 3D objects. So I have a position, so it is in 3D space. So in FireMonkey 3D we have the X dimension goes to the right, the Y dimension goes to the bottom of the screen, and Z dimension goes into the screen. So for this simple demo, I'm going to keep the position to be in the center. I have also a rotation angle, so in case of the sphere does not really make any sense, but I'm going to change the rotation angle Y property to mimic the rotation. And here I have a scale, so everything can be scaled. So I'm going to make my Earth slightly bigger, so I can scale independently in 3 different dimensions. Okay, so my Earth looks kind of red, so that's not something that I would like to have. I need to use a special material component, in my case texture material component, and I'm going to load this bitmap of Earth inside of this component. Load. So I have a special textures library here. I'm going to click on OK. So inside of my texture material component there is the image of Earth. I need to make a connection between my sphere and a texture. So my sphere component has a material source property. I need to hook up the texture, and now I have a great looking Earth. Okay, so that's a good starter, but I want to add some animation to it. I have an animation components. I can just double click on a float animation component, and notice that it was added to the Earth, so I can now conveniently animate different float properties that are part of the sphere component. So I need to specify the name of the property. So in my case this is going to be rotation angle Y. I need to make sure that this animation is enabled. I'm going to make the duration from a default 1/5 of second to, let's say, 2 seconds, so it does not spin too quickly. I need to make sure that I'm looping, so it's not just one rotation but continuous rotation. The start value is 0, and I'm going to have -360 for the Earth to rotate in a correct way. Okay, so in this way I have already got the sphere with Earth and also get some rotation. Now I need to add some interactivity. So I can, if I click on Earth and go to the events, I can see that there are different events I can respond to. So the most simple event is the on-click event. So in my demonstration, I'm going to, when the user clicks on Earth, I'm going to move Earth either further from the viewer or closer to the viewer. So first I'm going to actually change the default location of my Earth to be something further from the viewer. So I'm going to make the Z property 5, so my Earth is a little bit deeper, and I'm going to check in the onClick event where is my Earth, and then I'm going to animate the position Z property to move it closer or further from the viewer. So let's write some code. So if my Earth position Z property is more than 0, then I'm going to change it. So I'm going to do something like this, Earth, and there is special convenient method animate float, and I'm going to specify the name of the property as a string that I want to animate, so the position dot Z, and the new value will be -5, so the Earth gets closer to the viewer. And if we are already close to the viewer, we are going to do the opposite. So I'm going to change this line of code and just add here, I'm going to add 5. Okay, so now this is my logic. So this is standard C++ code that I'm writing. I need to save my application somewhere so it's easy to see. So I'm going to add a new folder, Earth CPP. Okay, click on unit 1 and my project. So I'm going to save my project as Earth CPP. Okay, click on save. And now the next step is to actually compile my application for different platforms. So I can use any of the compilers. So I can compile the same application to be either a desktop application or mobile application. So first let's start with compiling for Windows. So this is my application. Notice that if I click on the Earth, it's actually going further or closer. So this is actually, I have not spent a lot of time to get already quite decent interactive 3D visualization. And now the same application I could compile for mobile, but I'm just, for demonstration purposes, I'm going to just compile for Mac OS. So if I just now run this, I should have this application compiled for Mac, then run on my Mac machine. So notice that this application is now using a completely different 3D APIs. So on Windows we are using DirectX, on the Mac we are using OpenGL, on mobile platforms we are using OpenGL ES, and this is something that the programmer does not need to worry about. So this is really a beauty of the FireMonkey 3D programming, that you can just simply switch to a different application. Okay, let's go for a next demo. So I'm going to actually now use a the model 3D component. So I'm going to create a new MultiDevice C++ application, but this time I'm going to go for a blank application. So this will give me just a regular two-dimensional form. So in order to be able to use 3D objects, I'm going to add to this format T viewport 3D component. So this viewport 3D component is useful because I can just use it as a 3D space. But the benefit here is that the form, traditional form, has much more events than the form 3D. So for example, there is this new on-touch event, so I can create applications with support for multi-touch, which is common on mobile platforms. So this is probably the better scenario if you want to create a 3D objects or 3D applications, it's probably best to use a traditional form and use a viewport component. So in this way you can easily use traditional two-dimensional components. I'm going to add a toolbar and maybe change from Windows to Android, and so I can just add some buttons so user has the access to application functionality, and now I can make the viewport to occupy this whole screen. So I'm going to make it align to the client. I can change this color of this screen to something different, maybe sky blue. So this is a second possibility. Now I'm going to actually use the camera component. So in a 3D scene I have a camera. I'm going to put a camera. A camera by default is positioned in the just Z-5, so it's a little bit towards us. I'm going to make it Z-10, so it's even more space on the form. I'm also going to use some light object. So this light object, notice it's belonging to the camera, so it has a position 0, 0, so it is relative to the camera. I'm going to move it a little bit to the side, so it is now have an X-5. Another useful component here is a dummy component. So I'm going to make sure that dummy belongs to the viewport, and this is very handy because I can use a dummy component to, if I add other components here, I can just change the scale of this dummy component very easily. So notice my viewport 3D has a property called camera that was automatically attached to my camera. I could have more than one camera on the screen, and also there is the property use design camera. So even though we have a camera on the screen, we will not going to see the view from this camera, but the camera that we use at design time. So it is slightly higher up and slightly to the bottom. So this is really important property to control. Now I'm going to actually use a special component T-model 3D component that lets me actually embed or load arbitrary 3D graphics. So I can add here, for example, there is a model 3D has a property called mesh collection. So this is a property I can use to load a model. I have a special models 3D. I'm going to have in the deep space team, I have a rock, a small rock that I can load. I can preview how it looks like. Oh, great looking rock. And notice that now I have a rock inside of my application. So in this way, if I just compile this application, I could apply some different rotations, I could add some movements, but this is a great starting point to actually creating arbitrary 3D applications with arbitrary 3D contents. So these are some really basic things, but in the third example that I have already a pre-built example that demonstrates how you can use 3D to actually give an extra angle to your traditional business applications. So in this demo I have a two-dimensional form with a viewport 3D component that occupies the whole screen, and I have two layers. So this is very convenient component from the 3D layers, where I can actually use a traditional two-dimensional user interface elements to actually quickly build a typical user interface. So the layer 3D has a projection property that you can switch from a camera to screen. So if you want to actually mimic just the screen, then it's actually a good idea to change it to screen. So even though we are in a 3D space, but at the first moment it looks like we have just a regular 2D form. So let me maybe first compile this application and shows you what it's doing. So I have a list of different names of different customers, and if I click on a button, I can add an extra twist to my traditional, maybe boring user interface. So this is actually an example of using 3D just to add special effects to your 2D application. So that's really something that you can be very creative with, just changing the properties and animating the properties responding to events on a traditional code. So my application is structured in the following way: that I have a data module. On a data module, I have a client dataset component that I have loaded some customer data into it, and on my form I have used this unit, so it's all used. So you can see the include statement to my data module, and I have used visual live bindings, so live bindings designer, to actually bind data from a data set to different elements. So for example, this label 2 is bound to the company field, this label 1 is bound to a contact field, and I have other labels to display a more detailed information about a given customer. In order to create a navigation between the underlying records, I'm using action list, and I have defined using a standard action. I have used the navigate first, prior, next, and last actions, so they are all added here. It's important that you connect those actions to the data source, so the bind source DB has been automatically added to the form during defining visual live bindings to my labels. And now I can just use traditional speed buttons and assign them their action property to a given action, so they automatically get these captions, and also the end result is that I can navigate in the underlying data. So I'm going to run this application again just to show you how it looks like. Of course I could do it differently, but this is just to give you an idea that with FireMonkey 3D you can use effects, you can mix traditional two-dimensional user interface components to get an extra angle and extra twist to your applications. This is really very very quick, and I think that it would be very difficult to in just half an hour to give a deep overview of 3D capabilities of the FireMonkey. I'm sure that there are plenty of more complex scenarios that can be achieved, and I do recommend that you have a look into the wealth of the 3D programming in a C++ language with app method or with RAD Studio. Now I'm open for live questions. Thank you very much for watching this CodeRage 9 3D FireMonkey programming episode. Thank you.
Is there library support for translation of coordinates, Cartesian, polar, and so on?
Actually, in terms of coordinates, the one thing that FireMonkey 3D does in a very good way is that it supports DirectX and OpenGL from the same object model, and DirectX and OpenGL are mirrored. So FireMonkey 3D itself is doing some translations between coordinates, just so you don't have your Windows 3D applications just mirrored versus other platforms. But there are also plenty of associated libraries and code that comes with FireMonkey for doing all kinds of geometry manipulations, like there is a dedicated unit for working with vectors, matrices, doing different operations, working with arrays, doing ray casting, and also I'm not sure if out of the box you can have if there is a routine to translate between other coordinate systems, but it is something relatively easy to write. It's probably just two methods to go from one system to another.
Okay, and under the covers again, Paweł, FireMonkey has its own FireMonkey world coordinate system, right? And then those get converted to whatever the underlying hardware and operating system technologies are for 3D?
Yes, actually, that's very convenient because, especially when we are working with a multi-device development and also cross-platform development, actually the applications created in 3D scales very nicely to different form factors. So the same application, for example, the Earth application deployed to iPhone and maybe Nexus 7 or big iPad, they will all have a proper coordinates and the proper size, so it will not be so the Earth will be slightly bigger on a slightly bigger device. So this is really a great example of power of cross-platform development. With 3D views, you have really the same view across different programming languages, operating systems, and also form factors.
And again, there's if you check out the FireMonkey 3D runtime library source code and documentation, you'll see these where you can call transformations. So you can take a look.
Yeah, there is a lot of code behind it. Also, just during this session, I have put on my blog, on both the old blogs Embarcadero.com and also on the new community.embarcadero.com blog post with links to the source code from the all three demos that were presented, so you can play yourself.
Excellent. Let's see. Michael's asking, which 3D drawing programs are supported by these file types? How does import work? So I guess he's talking about 3D models, maybe?
Yeah, so there are different 3D file formats. 3 of them are actually supported by Model 3D component. So it's DAE is a file format that is text-based file format based on XML. It's from Collada. So these are actually exchange file formats. So different programming environments like 3D Studio Max, for example, or other environments, they would typically have their own custom private proprietary binary format that is optimized to work with a certain environment. But then there are these 3 formats were actually chosen because they are useful in order to export data. So in many 3D environments, they will have an option to export to different file formats. And so you can use any of these 3 supported file formats to import the 3D data into your 3D apps.
Don't we also have a sample program that imports 3ds, but it's not the component doesn't import that, but I thought we shipped a sample. Maybe that was a while ago.
Yes, there is when you install. I think I'm not sure if I'm sure it's part of RAD Studio. Not sure if it is a demo for app method C++, but there is a demo that demonstrates loading some of the 3D files, and also some of the 3D models from the public domain are included, so you can work with those files.
Another thing I've done when I have certain 3D models I want to work with, I'll use SketchUp Pro. There's an 8-hour trial from Google, and the Pro version, 8 hours, all I use it for is loading a model and exporting it as another format like DAE, for example, if you have some 3DS model or some other model. So I've used that successfully, and you can do it very quick, so you only use a few seconds of conversion. There may be other conversion tools, but SketchUp 3D Pro from Google trial, 8 hours worth, works for me.
Yeah, I think that's important to mention that the last demo was more around the traditional enterprise database application. So you could have built, for example, a game in AppMethod or RAD Studio, but we have a very strong focus on really building an enterprise database applications. And with 3D capabilities, you can really add to your traditional, sometimes boring database-driven user interface some extra angle that will make your application stand out. Also, in the typical application, both desktop and mobile can be made of multiple different forms. So in general situation, your application can contain maybe 10 traditional forms, and you can add 2 3D forms to add some extra 3D visualization, some extra functionality to your user. So this is really also useful in the context of just building a regular line of business applications where you want to maybe do some scientific visualization, maybe you want to make the interface more innovative, more interesting for the end user.
And then a question. Oh, wait. Okay. So a question I was having also about, we programmed a FireMonkey, but under the covers on the different platforms, it's different runtimes, and even we support hardware, the chips, the GPUs for certain operations like pixel shaders and so on. If someone wants to mix FireMonkey and also do some OpenGL, wasn't there a more recent release, I forget if it was XZ7 or XZ6, where you can get at the OpenGL, for example, context and do some special operations? I'm trying to remember if that was true or not.
At the end, it's important to realize that FireMonkey is just a layer on top of the regular 3D APIs. So if you are using Mac or you're using any of the mobile platforms, this is just an abstraction on top of the real 3D APIs that other programming languages and environments would use anyway. So you can, by looking into the source code of the FireMonkey and especially 3D, you can actually see places where the context 3D is actually used. There are lots of if-devs for different programming platforms, and also typically we have just classes that are neutral, like abstract classes with different virtual abstract methods and interfaces that are providing a common abstraction for doing a specialized programming on different specific platforms. So you can actually see inside of the source code to see where you can get access to the handle, to the context 3D, and then you can use just a low-level 3D APIs on a given platforms to maybe add some special functionality that FireMonkey 3D does not provide abstractions for.
Okay, so we have Paweł for a couple more minutes. If you have any other questions about 3D programming, FireMonkey, we've got Paweł with us. Just put him in the Q&A log, the question log area.
I think if there is I'm always interested in doing 3D programming, and if any of the audience has a specific request or something that they would see inside of the FireMonkey framework, and maybe they have a wish, I think that's a great opportunity to either contact us directly or maybe put it into the question pane. Comments about the 3D. I wonder how many of you are actually doing 3D, and for how many of you it's new. So I think that's a very interesting world of the 3D development, and FireMonkey makes it so easy to build great applications with just minimum coding. If you want to create a 3D applications in other languages and other frameworks, typically you have to do a lot of low-level 3D mathematics, work with matrices, and all kinds of things. So this is really makes your life so much easier that you only need to write some code, maybe for the application logic, but not for the very, very basic things related to working with the vertex buffers and all those fancy low-level things that other developers need to do.
So I put up on the screen your blog post. It's in the Q&A log now and in the chat window. So if those of you that want to click on the link in the chat window, you can get to Pawel's blog, and then you'll have the links to all the source code and so on for the samples that he showed. So that's there for you. You can just click on the link or copy it. Let's see. Michael's saying, I worked in the movies. I'd like to see some effects support, but it may be more advanced. No reply live required. So Michael, I'll connect you with Paweł. We do have image effects, a whole range of image effects and animations. Right, Paweł? But maybe
actually, that's very interesting nowadays when we have more and more powerful hardware. So most of the things we are doing is in the CPU, but the GPU, the graphical processor unit, is very powerful and very performant with not just a couple of cores, but hundreds of cores. And there is more and more initiative to use this for calculation. So also inside of the FireMonkey, we use shader programs that are actually powering some of the effects that you can use for traditional 2D applications. So there are some demos inside of the demo directory where you can see and how great effects you can use, basically using the same technology, using the shader components, shader code running in the GPU for doing transformations. So these are primarily for doing 2D transformations. So maybe in the future we'll be able to use it more and more for doing arbitrary effects also in the 3D space. I think there is plenty of room for innovation, for doing interesting new generation user interfaces, visualization, and more interesting apps in general.
Yeah, and Michael responded about more 3D animation things, Krakatoa and others. I mean, there's lots of fun stuff going on. We haven't focused, but someone could create a FireMonkey 3D library of components to do all sorts of things. I know some people have played with some of the physics engines, the 2D and 3D physics engines that are out there for doing things with games and movies and so on. But
yeah, also this is very interesting in the context of doing a C++ development. So the C++ is the language of choice for many 3D programming professionals. So many of the existing physics engines like Box2D or, for example, the Bullet 3D engine are written in C++. So you can basically use this cross-platform C++ code in your C++ builder or app method code. There is also, I remember a few months ago, there was a FireMonkey Object Pascal translation of the Box2D engine, the physics 2D engine with support for FireMonkey visualizations. This is also a very interesting opportunity, really adding physics to your 3D applications can even move it to the next level in terms of how attractive they are.
Okay, perfect, Paweł, and everyone. Thank you for this session.